Hello and welcome to this session. Here we are going to take a look at a second example for applying the Liskov substitution principle in a different way. Let's get started. We have a generic product class. We also have an in-house product class that extends the generic product class. Just think of it from the perspective of an e-commerce website like Amazon. Amazon sells a number of products on its website, mostly from third-party sellers, but Amazon has its own set of products too, which they manufacture in-house. I think they call the brand line as Amazon Basics, so that's what I mean by in-house products. Assume all products get a base discount of 20%. But if it is an in-house product, it gets 1.5 times the existing base discount. So if the base discount is 20%, then an in-house product will get 1.5 times 20, which is a 30% discount. This is the hierarchy that we need to implement. Let's start with an initial version. We have a product class which has a discount variable and a getDiscount method which returns the discount percentage. Then we have the in-house product class which has a applyExtraDiscount method that simply takes the existing discount and multiplies it by 1.5. Note that the in-house product does not override the getDiscount method, so it will simply inherit the getDiscount method from its parent, the product class. We will now use a bunch of these product and in-house product objects in another class. This class is named PricingUtils. It instantiates 3 objects, 2 of them generic products and the third one an in-house product. Note that all 3 are of type reference product. Next, we iterate through this list of objects which we just created. For the first 2 products, the if condition returns false because they are not in-house products, and so the instance of operator returns false. So it skips what is inside the if condition and it simply prints the discount for each of the 2 products. For the third product though, because the product is an instance of in-house product, it gets inside the if condition. Then it calls the applyExtraDiscount method which multiplies the existing discount by 1.5. Then it exits the if loop and prints the final modified discount. What we are seeing now in this utils class is not a good design. This is against the Liskov substitution principle. We should have been able to deal with all the objects as product objects itself instead of typecasting to in-house product for some of them. So how can we restructure the code to achieve this? First, we will override the getDiscount method in the in-house product class. The overridden getDiscount method in turn will call the applyExtraDiscount method. Now we'll do the corresponding change in PricingUtils. No change to the product instantiations. That part remains the same. The only difference is that the instance of check is now gone. We do not need to bother if the objects are instances of generic product or instances of in-house product. By doing this, the Liskov substitution test gets passed now. So objects can be substituted by their subtypes without affecting the correctness of the program in this particular example. So we have the product reference here, but it contains an in-house product which is a subtype of product. Still, the program works as expected and its correctness is not affected. This is a second pattern of problems where the Liskov substitution principle is applied. The solution to this pattern is called tell, don't ask. What this means is that, let's go back to the initial version of the code for a second. Here, we are asking or inquiring about the subtype from inside the utils class. But let's go to the final version now. Here, we are telling the utils class. The utils class does not need to ask anything. This is what we mean by tell, don't ask. So to sum up, we saw two patterns of problems. The solution to the first one was to break the hierarchy, as we saw in the racing car example, and the solution to the second one is to restructure the code so as to follow the tell, don't ask rule. That's it for this session, and I'll see you in the next one.